Hey everyone, and welcome! We're gonna go on a quick little journey to uncover the full story behind a shape we all think we know, the triangle. But it turns out there's way more to it than you might think. So let's kick things off with a simple question that has a surprisingly deep answer.
So take a look at this. We all know it's a triangle, right? But what if I told you triangle is just its first name? To really get its true identity, you need its full name. So what in the world could that be?
Okay, here's the big idea. Think about it like this. You can describe a person in a couple of ways, right? Like they might be tall and kind. Well, it's the same for triangles. Every single triangle out there has two specific names that, when you put them together, give you its complete identity. Just one name never tells the whole story.
So let's start by finding a triangle's first name. And the way we do that is by looking really closely at the length of its sides. This is our very first clue.
You know, when it comes to a triangle's sides, it really just boils down to three options. If none of the sides are the same length, we call it scalene. If exactly two sides match up, it's an isosceles. And if all three sides are perfectly equal, well, that's an equilateral. Each name tells you something very specific about its shape.
All right, so we've got the first name down. Now it's time for the last name. And for this one, we have to look inside the triangle, at the size of its corners, or as we call them, its angles.
And again, we've only got three choices, and the magic number here is 90 degrees. If all three of its angles are smaller than 90 degrees, it's an acute triangle. If it has one perfect 90-degree corner, like the corner of a book or a piece of paper, we call that a right triangle. And if it has one angle that's even wider than 90 degrees, it's obtuse. Okay, so we've got the first name from its sides and the last name from its angles. Now for the super important part, putting them together to find out a triangle's real identity. And this is it. This is the big rule that ties it all together. A triangle doesn't get to choose between a name for its sides or a name for its angles. It gets both, every single time. This combo is what makes each triangle unique. Let's see how it works. Let's say we have a triangle, and two of its sides are equal. Okay, so its first name is isosceles. Then we notice it also has a perfect 90-degree angle, so its last name is right. Put them together, and its full name is an isosceles right triangle. See? Simple as that. Let's do one more, just to lock it in. Imagine a triangle with three equal sides. What do we call that one? Yep, equilateral. And if you were to measure its angles, you'd find they're all less than 90 degrees, which makes it acute. So its full name is an equilateral acute triangle. See how that works? You know, this whole process really shows you how important just observing carefully is. The source material makes this interesting connection to the story of Gideon, but the main point is really simple. To truly get what a shape is, you have to look at all its features, the sides and the angles. That's where the whole story is. Okay, so now that we're basically expert classifiers, let's switch hats and become architects. We know how to name them, so let's figure out how to build them with real precision, drawing our own little geometric blueprints. And you don't need a lot, just these simple tools. Just think of the ruler as your first name tool. It's for the side lengths. And the protractor is your last name tool. That's what you'll use for the angles. So let's start with an equilateral triangle. Go ahead and grab your ruler and draw three sides that are all exactly, say, 6 centimeters long. Now, if you check it with your protractor, you're going to find that each angle is exactly 60 degrees. And since 60 is definitely less than 90, you've just built yourself a perfect equilateral acute triangle. What about a right triangle? Well, this one is all about that one special angle. Just draw a flat base, then use your protractor to make a line going straight up at a perfect 90-degree angle. Then, all you have to do is connect the ends and boom, you've got one. You've just built the foundation for so many structures in the real world. And finally, let's make an obtuse triangle. The trick here is to start with the angle itself. Use your protractor to draw a nice, wide angle, something more than 90 degrees, like 110. Draw your two lines coming out from that point, then just connect the ends. That one wide angle is what defines its whole shape. So the next time you see a triangle, you won't just see a shape, you'll actually see its full identity. You're officially a triangle detective now. Which kind of leads me to a final thought for you. Which of these types, the right, the acute, the isosceles, which one do you think you see most often out there in the world? In buildings, bridges, or even in art? Once you start looking, I promise you are going to see them everywhere.